So yeah, my name's Jamie. This is Adrian. We're from Rightmove. Today we're going to talk about the scaling of the Elastic Stack that we use in the microservice architecture. We're going to go through some of the challenges and tips and tricks we picked up along the way. So we've got about 3 years. When the screens come on, there will be a lot of information, so don't worry too much about the notes. We're going to provide a PDF link. Just to give a short background on us, if you don't know who we are an online property portal where people use us to search for houses. We have at the moment about 60 million hits a day, and our core search at the moment is also Elasticsearch. When we started using Elastic Stack, we actually had no microservices at all. Now we've got around 50, and they're going up pretty much every other week at the moment. Cool. So before we had the Elastic Stack, how would we debug an issue? So back in the day before microservices, we had up to 90 monolithic web servers spanning across 3 data centers. So if you wanted to find some information from those, you can see something horrendous like this. I can't actually remember exactly what it does. Something like going through every public site server, trying to get the top number of IPs, sourcing them, and then finding basically who's hitting the site the most. Obviously, you can't graph this. It's a bit of a pain, and it's not live. So then the hackathon 2014 came along. We heard about the elk stack, as it was called at the time, and we thought we'd do something about it. So for those of you who remember that meme of measurable things, that's what we called ourselves. You can see a Cabana 3 graph there, it's going in the right direction, which is great. And that's
a number of attacks on the side.
Not bad. Maybe it's a mirror image. I'm sure. So yeah, the idea was to kind of figure out exactly what we could get from our access logs at the time. And in fact, we actually ended up answering other people's hackathons. So there was another hackathon in another team that was trying to find out the most popular properties on the website, and actually we answered it using our own hackathon. The business immediately saw the value, and we were ready to go. Cool. So I'm going to talk now a little bit around some tips and tricks around installing and configuring it. Just a word of warning, we are on 2.x at the moment still. Obviously, 5.x is the mainstream at the moment. Most of these things do apply to 5 as well, but where possible, I've provided links. Okay, so most of this is probably obvious to you already, but in case it's not, make sure you use configuration management. You can obviously use any of those ones. Pick your weapon, just make sure you use one. As I say, the official public module that we use is fantastic, and I've provided a link to it there. You can pretty much do everything you really need to. It makes it easier to scale. Adding nodes, the node fails, you can bring one straight up. You can add this, update configuration, etc. And it's also really good if you use Vagrant at the moment. You can model all your changes locally and test them before you actually push them to the data center. Okay, so as I mentioned earlier, we have 3 data centers. And we wanted to have a single view of Cabana, but we were told that you can't actually run a single cluster across multiple data centers. Well, you can, but it's not really supported. Latency is an issue, throughput's an issue, so we had to have 3 separate clusters, one per data center. So how can we possibly get a single view on Cabana? The answer to that is using something called tribe nodes. It's not massively advertised, but it's really good. And you basically point your Cabana at the tribe nodes, and they will basically aggregate across the 3 actual Elasticsearch clusters. So the clusters, the index names must be unique on each cluster. And I've got an example there. So for instance, if you've got access logs, make sure it's DC1, DC2, DC3, and then you can create an alias or prefix that will basically search across all of them. And just a word of warning, if you're on 5, you need to be on 5.2 minimum, because there is a bug before then, which actually stops tribe nodes from working correctly. There's more details on that link on how to use it. The other thing, which I really recommend you do, is to create a buffer between your apps and Elasticsearch. Again, there's lots of different ways you can do this. We've used Redis. If you've already got Kafka or RabbitMQ, feel free to use that. What this basically means is you don't want your Logstash instances directly connecting to Elasticsearch, because Elasticsearch doesn't really handle concurrency very well. And it's also, it allows you to handle potential outages or surges in traffic that you might have. There'll be a bit more information on this later from Adrian. And it helps avoid bulk projections. So bulk projections basically mean you're losing data. It's not good. So make sure you have a buffer between your apps and Elasticsearch. Hot warm architecture. This is another thing from Elasticsearch. So there's a link there for version 1 and version 2. I believe on this link it also links off to version 5, but it's pretty much the same configuration. So what hot warm architecture means really is it's basically tiering. So if you imagine you've got your Elasticsearch cluster and you want to index your data, you have to have quite fast disks to do that. So you really want SSDs to index live, especially if you're running a lot of data through it. Obviously, SSDs are quite expensive. So if you want to store data for a lot longer, you have to pay for that cost or put them on SATA. So what the hot warm architecture allows you to do is split out your data between SSDs and SATA. So effectively, you tag them with a tag. These, for example, you can call them whatever you want, and you make sure that your log stash, when you send data to it, the settings connect to the hot nodes. There's more details in the link. And then when the logs roll over, or the indices roll over, I should say, you use a product called Curator. Again, this is by Elasticsearch. This will allow you to basically move that data onto your warm nodes, which are basically full of SATA disks, big disks, and they store them for a lot longer. So obviously, indices that are older, they're not being indexed anymore, so they don't need fast disks. Cool. A couple more general configuration tips. I'd highly recommend making use of Shield to secure your write operations. If you don't, anyone by default will have access to modify or potentially delete your data, whether that's accidentally or maliciously. I'd also recommend incorporating without that if you can, so it just makes it a lot easier. Give Elastic half the available RAM. Elastic say kind of a limit of 31 gigabytes. For Java, that's kind of to do with like an internal Java limitation. Turn off swap. If you have a swap on, it can potentially cause garbage collection to go through the roof. And also make sure you back up your Kibana index. Again, as I said, if you don't secure your Elasticsearch cluster with Shield, potentially any user could delete Kibana. And also, any user that has access to create or edit dashboards or visualizations also has the ability to create and delete visualizations. So make sure you back it up. And actually what we do internally is we create a read-only anonymous user that's a well-known user. That user has access to be able to read from the Kibana index, which means we can actually open it up to the rest of the business and anyone can actually look and improve the data. So it's actually allowed us to grow Kibana internally and get a lot more people in the business actively engaged in it. Cool. I'm going to hand over to Adrian, who's going to talk about configuring logs.
Cool. So I just wanted to talk a little bit about how we do stuff on the kind of application side of things. When we were coming up with this stuff for our log collation system, we had a few requirements that we wanted to make sure that we met when we were choosing. One of the things was it needed to be flexible, so we needed to be able to read for both our new microservices and for our legacy applications. So the system we built had to be able to do that. It needed to be consistent where possible. So we've got 50-odd microservices Jamie mentioned before. We want to make sure that they are logging in a similar fashion so that we can merge all the data together. If not, then it becomes quite difficult for us to make any kind of inferences and graphs across the data sets. And also it minimizes the amount of configuration that's needed by the developers to actually roll things out. Which leads me on to the fact that we needed it to be easy to configure. So developers needed to be able to do things easily and add just a few lines of configuration for each one of their apps to actually get logging to happen. And then also our log stash configuration needed to be separately deployable. So we wanted to be able to change our log configuration separate from our applications. So we didn't want to have to keep redeploying each application instance every time we make a change to the logs. So you want to be able to make sure that we have that as well. So to give a bit of background, we use a few common log types. Some of them you probably have seen before if you've come across any logs in the past. So access logs, everyone sort of has those. It tells you your incoming request data along with any relevant metadata that you've got for your requests. We also have what we call our client response logs. So for our microservices, these are logs that track outgoing requests from a service. So they will track the request going out and then the response coming back in and mark the application names. That allows us to do some interesting things about tracking stuff for performance reasons when things go wrong or when there's issues, but also another thing which I'll show you later on in the talk. Error logs, lots of errors in them, everyone's got those. App logs, so app logs is where we kind of get developers to write those generic log lines from your applications. So giving information about activity that was going on at the time so that we can cross-correlate it with what was going on with any activity or errors at the time. We try to keep custom logs to a minimum for a number of reasons. We do have special cases though where certain business units want to be able to use things in certain ways, so we make use of individual logs for those, which allows us to have different data retention rules. In general, at the moment, we're keeping about 2 weeks worth of data for most of our logs, but we have some that have been ticking over since the beginning of last year and things like that as well. So how do we ensure consistency across our applications? So one of the things that we did was use a common library that we built ourselves that wrapped up Log4j. We're a Java house. You don't have to be a Java house to do all this stuff. I just recommend having a common way of making sure that when people are building their applications, there is an easy way for them to log in the right way. It makes it common and consistent for people. So we log in JSON wherever possible. This saves on building horrible grok parse message things in your Logstash configurations. And has a side effect of encouraging people to view their logs in Kibana, because if they SSH onto the box and try to look at the logs on the machine, good luck trying to read a load of brackets and with your lines and things. We also add in correlation IDs. So correlation IDs are ways for us to track requests across applications. So they're a unique identifier that allows us to say, this request started on this application, it gets passed along in the headers to the next one. That one, then whenever it logs, will also write that in there, and it allows you to correlate messages and figure things out a lot more easily. If you don't have that kind of methodology, it makes it very difficult to see what changes need to happen to fix something. We also support key value metadata and tags in our access logs and our app logs. So we have in our logging library the ability for developers to add in key value pairs or tags. So for example, say it's our searches, and we want to be able to graph the postcode searches different from the region searches, different from station searches, things like that. So we can introduce tags that identify that this search that came in was one of these types of things, and allows us in our graphs to be able to separate them out later on when we're doing terms aggregations. So what does our setup kind of look like? So bit in the box is a kind of instance of an application. So this is repeated for as many times as we have apps. So the app will be writing to its log files, and then we'll have an application side Logstash that will be sitting there reading from that. We try to keep as much of the configuration on the application log side, because this allows us to spread out the usage of the complex changes and stuff that need to happen inside of Logstash, rather than doing it all at the end before you put stuff in. Because you're making use of all your distributed CPU and memory and things like that across your application. So it's a really good idea to try and do this kind of thing rather than just jam a load of stuff in your pipeline at the end, which will slow down your ingestion. Then we have a Redis queue in the middle. We just create a queue in Redis for each type of log that we have, and every application will add to that queue. And then we have a publisher Logstash on the other side. Publisher Logstash is literally configured to read from there, set up a template in Elasticsearch, and then write the values into Elasticsearch. So what does our configuration do? How do we store it? So we store all of our Logstash templates in source control. We use Bitbucket and Git. And then what we do within our Logstash configuration project is we have a folder that represents each type of log that we support. Developers are able to add their own log folders there. And inside each one of these log files, we contain all the Logstash DSL required to pass the log lines and pass them on to Redis. We do these as templates, so it allows developers to say, I want this one and I want to add it to my application, so then we can instantiate an instance of that template for their app, which I'll go into in a second. We also have a special folder within that stuff called the publisher logs. So this represents that right-hand side of the diagram that I showed you before. So this contains all the log stash configuration required to read from those queues and write to Elasticsearch with the right mappings. And we also store our mappings alongside it as Elasticsearch templates. This allows us to set up all the key field and value stuff. It allows us to set up all of the analyzers, all of the shard settings and things like that in a central location. So how we deal with different data centers and different environments is we use placeholders in these configurations. So what we do is, as you can see from this little chunk from a bit that we have, we use this kind of $wiggy bracket notation on the logstash configuration files. And what that allows us to do locally is when we build through with our build systems, we can replace these depending on which environment and which application we're deploying for, which allows us to say, right, for QA, we can put in stuff here. For production, we can change the path depending on where things are deployed to. And for local, with stuff being run within our local testing instances, we can do stuff with that there as well. And then finally, when the actual bit that most developers actually get to see and use every day is just this YAML file that we have. So once we've defined most of our common log types, they don't often change very often. Some people will come in and add a few extra things every now and again, and we'll make tweaks to some mappings. But when you're creating a new microservice, you want to make it easy for developers to add the same kind of logs to all their apps. So what we do is we define an entry in that file for each application that we have that also has a following list of templates. And these match up to those folders that I showed you before. So when our build system runs over it, it splits it out, looks at for each one of these guys, instantiates an instance of it, plugs in those placeholders, and then zips it all up into a tar file. So there's a few things that I want to kind of get across that we've come across when we've been doing our logstash configurations that we thought were quite useful. It may seem obvious, but make sure you separate your staging logs from your production logs. You want to stop noise from your tests infecting your production data and giving you any kind of false negatives or positives about stuff that's going on. This also allows you to start testing your log changes before they go out. So if you roll out some new configuration to do your staging environment first, it allows you to see those logs being ingested from your staging apps before you roll out to production and break everybody's log files. I also recommend adding in application names and any data center or availability zone information into your logstash configurations. So we do that with those placeholders when we deploy, because we know what we're deploying for and where we're deploying to when we create those configurations, the instances. So we can then, when we get our graphs later and see that the things are going wrong, we can see whether or not everything that happened in a particular data center is at fault, or whether it's individual instances within that data center. Don't analyze fields that you want to be able to group by. By default, if you don't do any mappings in Elasticsearch, it will analyze your strings. And what you want to make sure is that you have turned off the analyzing for any of the things that you want to group by. Now, if there's things you want to group by and to standard search across, then I'd recommend creating multiple field mappings from the same value. So we do that with a common pattern name. So we have our host.raw. If we're doing it for a host field, for example, which would be the unanalyzed version, and then host would be the analyzed one. And I can't say this enough, try and minimize the number of shards that you're using. It can be very easy when you're building out loads of logs for different environments that you'll end up creating tons of shards. But in Elasticsearch, each shard is an instance of the scene. So you want to make sure that small logs are kept on single shards where possible. Don't spread them out across loads of different shards when you can keep them on a single one. If you're using rolling indices, remember that template changes only take effect once the indices roll over. So if you have mappings and templates that you're applying and you make a change halfway through the day to it, that template won't automatically apply to your data until the index is recreated. So if you do want that to happen at the same time, you have to make sure you update your mappings at the same time as updating your templates. Otherwise, you have to wait till the next day for your stuff to get created if you're using daily rolling logs. If you're trying to if you're doing daily rolling over indices, try not to do it on small ones because you'll create loads of additional shards that you don't need. You can get Logstash to roll over monthly, yearly, whatever you need to do. it just saves on you creating tons and tons of instances that we've seen that are doing very little work and taking a lot of resources. And also, as Jamie touched on before, make sure you have a way of clearing away your old data indices. Unless you've got a load of disk space, you're going to run out very quickly. So we use Curator, as Jamie mentioned before, to do that. So for our deployment, we build all of our configuration through Jenkins. So we build pipelines that allow us to deploy all of this Logstash configuration set from our applications. What we do is we bundle it all up into a tar file that we keep in our Nexus repository. And then what we do is we use a Jenkins seed job that will create a pipeline for each application, which has a split for staging and production, which then allows the devs and QAs to run these pipelines and deploy the new Logstash configuration. So first they can run it, deploy it to staging, confirm that logs work from looking at them in Kibana, and then deploy to live once they're happy. So our pipelines look a bit like this. So we have one at the top here that's all of the Logstash configuration. So that gives us the ability to roll out changes across the estate. Then we'll have an entry here for each one of our applications that allows us to individually roll out things. And then we drill into those. These are our pipelines. So we have one for QA, one for production, and that's kind of dealt with by the seed jobs. We also generate that based on that YAML file that I showed you before. Seed job looks at that, sees all the applications that it needs to be able to deploy to, and then also generates the pipelines. So we test this locally as developers. We don't want to have to wait until staging if we're doing some development work to work on things. So we use a Docker Compose stack that mirrors our production setup. So I've got a link to a similar type of thing I've got here. It doesn't have the Redis stuff in it, but it's got a very similar way to what we do. So we use Docker Compose to set up the little diagram that you saw before. We've got an application Logstash, we've got a Redis instance, we've got a publisher Logstash and 2 instances of Elasticsearch, and then we'll install run Kibana at the same time. And then that just allows us to drop the sample log files into a folder within the Docker container, build it out, it will copy them across, and then you can then get to read them through your very own instance of Kibana and check things out. It makes things a lot easier and a lot faster to know that things are going to work before you put them out. If you do that and you're using old log files as a sample, remember to put these bits in at the beginning of your file input. So in Logstash, if you don't put these in, obviously it's only going to read from the end of the log. So you want to make sure that you set it to the start at the beginning. Logstash also uses these little files called sensDB files. And so what that's for is that when Logstash is running, it keeps on track of where it's got to in a file. Now, if you're doing testing, you often want to just keep reading back from the top of the file again. So if you want to make sure that it doesn't keep track of where it was before so you can re-ingest the data, then make sure you send it to dev null, because that'll just make sure that all of that information gets knocked into oblivion. And this is one thing that caught me out a long time ago. But certain versions of Logstash, the file input plugin will only read logs that are 24 hours old. If you do not change that, if you put an old log in there that you've been doing some development work on, and you come in the next day and it's been more than 24 hours since you created that log, you'll suddenly see that nothing's working. What's going on? And you're working through it, trying to figure it out. And then you dig through the documentation and you see this thing. So ignore older, unless you set a number of milliseconds that you want a file needs to be the age of to get ignored. So this is something like 30 years worth of milliseconds, but so you can set whatever you want to. But if you are doing testing, make sure you set that, because otherwise you'll find that your logs aren't necessarily getting ingested. Cool. So I'm just going to pass back to Jamie to talk a little bit about how we monitor and maintain our Elasticsearch.
Cool. Okay, I'm just going to go through a couple of monitoring tips. So, very standard stuff. Make sure you're monitoring your CPU, your memory, and your disk. Something quite specific, Linux will loop the rest of your RAM. For those of you that aren't familiar with Linux, you might not know this. There's a great website called linuxaidmyram.com. So it's generally used for the loosening caches, basically. So if you're setting half the RAM for Elasticsearch, you will see the other half of it being used by loosening. This is completely normal, do not worry. Quite a basic one, at least monitor the cluster health. So get_cluster/health. I would recommend alerting on yellow. If you alert on red, it's too late, the cluster is down. And bulk rejections. So as I mentioned earlier, if you get bulk rejections, you're basically going to be missing data from your cluster. So you kind of have to weigh up how critical it is for you to keep data. So if it's absolutely critical that data is going into your cluster, then obviously look for a number that's 1 or above. Finally, If you've got the other settings, you can basically have monitoring and alerting, which I won't go into now, but you can look them up online. Okay, this is a very specific one that we got caught out on. About a year and a half ago, our Elasticsearch cluster at one site was crawling. We're getting lots of bulk rejections, as I just mentioned. We couldn't see anything immediately wrong. CPU was looking okay, memory was fine. Disk looked okay from sort of a capacity point of view. Memory was fine, as I said. Logstash was trying to read from Redis. Redis was backing up. We were getting queues filling up from Redis. Redis was then crashing. And this was only happening at one data center. And we use configuration management, so all three of them should be the same. We spent probably about 6 weeks trying to get to the bottom of this. And then we discovered there was one disk in one node that had higher latency than the others. So disk latency can really, really kill your cluster. This is what it should look like normally on SSDs. So that's the average sort of wait time. And when we look back through our monitoring system, which we should have looked at the beginning really, this is what it looked like over a period of months. That's going up to 80 milliseconds sort of around May, June time. It was actually a problem around December, but as you can see, it's low enough not to really be too much of a problem. And then as the months went on, it got a lot worse. And it actually turned out to be a firmware bug with one of our servers. So this might not apply if you're using a cloud provider, but just be aware and monitor your disk latency because it can absolutely kill your cluster. And again, always use SSDs for live indexing. One fun thing, in terms of disk thresholds, you kind of want to set them lower than you would probably normally. Remember, Elasticsearch will replicate data across nodes by default. You need to be able to sustain failed nodes, which means that data is going to move if a node fails to another part of your cluster. And if you have multiple clusters and you have a failed data center in our example, that traffic is going to have to move to another Elasticsearch cluster, so that cluster is also going to get a lot more data arriving at it. So make sure you set lower thresholds, and obviously this depends on your use case. For us, if we've got 3-node cluster, we set the threshold at about 60%. So if we go over 60%, that kind of warns us that in the event of a failure in a node, we wouldn't be able to actually handle the amount of data coming into our cluster. Okay, back to Adrian for helping me combine it.
Cool. So I just want to go over what we use all this data for and how we use it. So we record all of our deployments in our elk cluster, Elasticsearch, I should say. So it allows us to see everything that's being deployed by who and when, and that allows us to do some interesting things with that data, which I'll show you in a minute. Performance, obviously that's quite a key element of having the Elasticsearch system in your environment. So we look at things like slow pages, error occurrences, and we use it to investigate issues and things that are going on inside our system. We use it operationally, so we look at email servers sending, we look at web scraping and IP blocking for some of the stuff here. For those that don't know, property websites are one of the most scraped type of website in the whole of the UK. So we get a lot of people trying to game the system and get their properties first, which is fine, but we have to make sure it's not affecting our stability of the site, so we have to keep an eye out for that stuff. Use it for capacity monitoring. We also use it for some business KPIs and statistics, so we use it quite heavily for looking at property update anomalies. We use it to look at features as well, so we have certain teams that look after certain features on the website, so they'll look at things like say properties and property alerts being created, so if that drops off then we know there's some problem with that feature or some change that we've made isn't working. And we can look at things like the popular properties, or what people are looking at. I think it was about 2 years ago, there was one property that ended up in social media that every single room in the house was purple. So it ended up skyrocketing, so it got shared on Facebook and everywhere else and across the world. And we ended up like, you can see our Google Analytics graphs from at the same time, and it's like, it's next day, it's insane. So I was going to show you the actual stuff, but I can't connect my VPN through that. So luckily I prepared earlier and took screenshots and everything just in case that would happen to me. So so we look at things like slow pages. As you can see here, this is a dashboard that we look at. So we're looking to see that we're within the 99.999 percentiles as close as possible, and things that are dropping below that then we want to look into. So this is from a time where we needed to look around some of the stuff that was going on here for some of our property search stuff. And as you can see, we can then graph those across the different percentile ranks, and then we can use these KPIs to send them out to people in the business who care. We've got our scraping detection. As you can see, this lovely gentleman has sent this number of requests in this short period of time. If you look at this graph at any one time, you'll always see somebody like this. I think this guy is a hosting provider somewhere in France, where they just continually scrape our website for about 40,000 hits a minute, which is nuts. But yeah, so we're looking out for these things, and then we correlate this stuff with our database usage across different applications, so we can see like, oh, when this goes up, and this goes up here, and so we can make sure that this is within a reasonable rate. Obviously 7x is all right, so it's not too bad. And then we can look at things like the sum of the duration for each of the calls that are happening per IP address that's coming through, and then we can also look at the user agents for this stuff. So when you hover over these, they tell you, is this coming from a Python script, and this one's coming from Java, and this one's coming from where else. So it's interesting to look at. We also cross this data, not just in Kibana, but with our own applications. So we build stuff using basic JavaScript frameworks and some Java Spring Boot applications that allow us to combine the data set we've got in Elasticsearch with other systems we have. So we have one called Deploy Versions. Deploy Versions combines the data set with the stuff we have in Bitbucket. So this allows us to have a look at how version history is going on in our systems. And it's quite straightforward setup when you're recording all your deployments. So you have all of your applications here, you can pick between all your different microservices, or you can pick as a team level, so you can pick a team and it'll show you tabs for all of them for your team. And then it'll warn you, so if you haven't deployed an application in over 2 weeks, like you're not really doing continuous delivery, which is what we're trying to push forwards on, so you're doing a little worse than if you were in our old deploy system, which happened every 2 weeks. So we try to make that obvious to developers. You can click on these links here, so these tell you what you will deploy if you're going to deploy. So you can click on that, that'll open up Bitbucket and it'll show you the actual diffing links. You can do the same thing with GitHub and all those kinds of stuff as well, because they're all got deterministic URLs you can plug stuff into, which is really handy. And then you've just got some information about deployment statistics, like who did it, so we have the developer's name there, how many things they did and what days they were doing them on, which is quite useful. In the same application, we have a deployment timeline as well. So we can pick a date range, an application and an environment, and then we can see who deployed when and what they deployed. And then we have a little rank deploys here to try and encourage different people to move themselves up and deploy more often. We're working on that at the moment to create some more graphs from this data as well to see what people's mean rates and rates to recovery and things like that in here as well. And then we've got a traffic visualization. So this client response logs I talked to you about before. One of the useful things about it is you can run Elasticsearch aggregations across them to see which applications talk to which other applications. So we can pick an application here, like our property search app, and then we can see all of the applications that it calls out to and gets called in from, and how often in a 24-hour period, which is really useful. Because then when you're showing people and explaining to developers that it's just started, or you're talking to business people about which things do what and what will the environments look like, you can do something like this. And then if you want to look at a larger part of the estate, you can get this lovely crazy graph. And then you can drag all these things around and separate it out a bit. It's quite cool. I wish I could show you in real life, but you get the idea. One of the other cool things that we're doing at the moment is we are trying to move to Watcher for some of our alerting. So we've built on top of the data set for Watcher a way of setting up alerts. So this is an example where we've got a list of these different alerts that we can have. We can edit them, we can delete them, we can acknowledge them when they're alerting, we can disable them, we can show everything that's going on there. And then we have a simple form that we then use to set up a watch. So the application itself is hiding away all of that Watcher DSL stuff, so that you don't have to know across the entire business how to set up a watch. You can then just go, I'm going to create a template in my actual Java application that's going to plug in these values into the right queries and stuff and save the watch for them. So you can pick your index that you want to look at. Because we know that all our indices contain application names, we can also say you can pick an application from that index and populate from there. One of the other stuff that we can do as well, because we know the indices, we can then filter down all the ones that are numbers, because we can grab the mappings from Elasticsearch and just say which ones of these are numbers. And then we can say we want the threshold to be above, below, whatever, set a value, and then set the average time that it needs to be at that value before we start alerting. And then we can say how often we want to run it, and then we can set some alert actions, so we can send emails and Slack messages at the moment, and then how long you want to throttle it for. So that's the Watcher where you're saying when this goes off, I want to throttle my actions for a certain amount of time before alerting again, and to give it a name. And then what we do is, because we're integrated with our LDAP, like we said before, developers can log in. This will get populated with the team that they're a part of, and then they'll save against the team. And then we can use that information to make sure that they can only disable and change the alerts that their team has created, so that people aren't randomly turning things on and off for other teams. So that's quite useful. So I just want to give a few tips about some of the visualization stuff that we're doing. So obviously, just remember, with all that data, you're not just limited to using what you get given in Kibana. You can use your own JavaScript visualizations with Elasticsearch queries. It's pretty straightforward. They both talk in JSON. So it's really, really easy to start mixing this stuff up together and getting the data back and passing it through. We use for the visualizations, so we use a library called BizJS. It pretty much gives you that network diagram and timelines and stuff for almost free. You just have to put the data into the right sources. And it allows you, if you're doing this, it allows you to combine your data sets from different systems that you have. So if you've got things like Bitbucket or Jira or whatever you're using to try and pull data off, you can kind of mix these things together in new ways. But what I would say is, don't rewrite Kibana's functionality. Kibana is really useful. So one of the things we're doing with the alerting that we're working on at the moment is Kibana URLs are deterministic. So when you share a URL to somebody, it's the same, and it has all the information in it. So if you know this is a set of alerts, you can plug those values into that URL and then show them the timeline for that alert. So we don't put like an alert history in our alerting app, because Kibana can do it for us, which is, and it's a lot better at it. So yeah, I'd say be careful though if you're using the Elasticsearch Java client. It's easy to get started with, and it's really well written, but it can make your upgrades hard if you're a Java developer. Because the way dependencies work, if you're on a dependency version for a particular Elasticsearch version and you want to move to another, unless you have two versions of that application running two different sets of the code base, it becomes quite difficult. For some of these internal apps, we try REST calls where possible. This allows us to just roll out different versions of stuff on switches. So we can use feature switches to control the setup of watches and things like that when things change, so that we can roll over, turn the feature switch on, and everything will work seamlessly, rather than having to roll out a new version of the application. Also, it may be obvious, but don't be afraid to have more logging to your to get the data you need. Like, if you've got a data set and you think, oh, well, this is really good, but I want to get this extra thing out there, think about just adding those extra tags and extra key-value pairs and things in that make your data more rich and more useful. Also, if you're building features, think about dashboarding when you're creating them. So think about what you can log to actually get information from that in a useful way. I'd advise, if you're trying to push the Elastic Stack in your company, run training workshops with the teams. That's what I do. So I make sure that I open out things about how Elastic Querying works. I talk about how to use Kibana and things like that. Because building these things, it's never enough. You have to teach people to use them. If you build the ball singing or dancing alerting system, or all singing or dancing way of figuring out your problems, but don't advertise it, then you'll find you'll be the person using it. And don't limit it to just developers and operations members. Like, we try to adopt in a opt-in kind of approach. So anybody who's interested, we can say, look, you can come along. All you need to have is a laptop with a browser for most of the part. So we can get lots of people from the business and other places coming in, figuring out how to use this stuff, which is really useful because it means that business and support team members can tell the teams what they actually want to graph. And then the developers can go, oh, I never thought of that, and add those things into their applications, which is really good and really useful. Can't say enough, be prepared to be a good example for others. If you are figuring out issues within your company and you're using the Elastic Stack, share graphs and your Discover results with the rest of your teams so they can see what you've done to get that data, and saving your visuals and sharing them with other people, because once you start doing that, they'll see, wow, I can get all this wealth of stuff out of this thing, and they'll be more inspired to do it. So you're going to have to be a bit of an evangelist when you're talking to your teams and stuff and standing up in front of them and talking about it and going, you need to keep doing this, it's really cool. Look at all this interesting stuff you can do. And also little like side things. Remember that the filter bar in Kibana doesn't just support the scene queries. You can put the entire queries from Elasticsearch in it. It's a bit weird. You end up with this great big long JSON blob inside this tiny little field, but it works. So if you've got complex queries you want to run in the Discover tab or whatever, you can put those queries in there and it will show you the results based on it, which is really, really handy. And also I recommend, like, if you're in the right positions, to have monitoring views with your team or teams. So sit down with them, like, get a discussion going about what they're monitoring, what they care about, and just try and help them see how to do that, how to get things through into the elk stack, Elasticsearch, I should say. So future plans. So depending on timescales, we want to upgrade to Elasticsearch 5/6. 6 is on the way. You can see all of the documentation getting all updated. It's all interesting. So that gives us performance improvements. It further allows us to reduce the number of shards because it allows us to control things using the index shrink APIs that are being introduced, and some of the rollover stuff that's in there as well, which is nice and tasty. It means that you can merge all of your indices together. So you only need those shards, the massive amounts of shards, when you're indexing. When you're querying, a lot of the time you can get stuff down to a single shard and do that because it saves so much resources. So we're looking forward to that. Use automated reindex tools to merge data. So we'd like to start doing that, as I just said, merging down to old indices into bigger ones, just to further reduce the number of shards we have. There's people keen to try out the reporting stuff in Kibana. At the moment, the version that we've got, we need to move to 5.2 before we can start using it, because of the way we use tribe nodes. So that can be something that can catch you out. But people want to be able to report these graphs and things to the heads of business about some of the KPIs. So we're looking forward to doing that stuff. We're moving to Docker in our company, so that's a whole talk in itself that I'm not going to go into. But we're looking at things like, because we want to be able to still deploy these log-stash configurations separately, so we're looking at things like the sidecar pattern and stuff like that allow us to deploy file beats and log-stash separately, and still allow us to keep going the way we've been doing things. And we're doing more stuff with watching and alerting, do more improvements on the alert types and things like that. So so thanks for listening to us. I'm Adrian and James. We're also looking for Java developers, front-end developers. If you know anybody or are interested, you can contact us or come speak to us and stuff. It's really cool. And yeah, if you've got any questions.